Hello everyone. In this video I am going to discuss about solution of non-homogeneous differential equations with constant coefficients. Generally we take a non-homogeneous differential equation as like this: f of d into y equals to q of x. Now general solution of this equation is of the form y equals to yc plus yp. Here yc is nothing but complementary function of this differential equation. Yp is nothing but particular integral of this differential equation. Yc, or we can say Cf. We can write y equals to yc plus yp. Solution of this differential equation is of the form y equals to yc plus yp. Yc plus yp. Yc is nothing but, this can be written as even Cf complementary function. Yp is nothing but particular integral. In my earlier video we were discussed how to find complementary function of differential equation. Now we are going to discuss about particular integral of this differential equation. Now first we will discuss method 1 or rule 1 when q is e power ax. How to find particular integral in this case. When q is e power ax, the method says that particular integral is written by like this: pi equals to 1 by q of x. Here q is nothing but e power ax, so I am replacing q with e power ax. Here a is a constant that can be real or complex number. Now in this case put or replace d with a. Wherever d is there, write down a. We get like this: 1 by f of a times e power ax. If this denominator is not equal to 0, we take this as required particular integral. If this denominator is 0, in this case particular integral is given by, we write x in the numerator, we differentiate the denominator with respect to d, we write 1 by f dash of d, and here q is there. Here q is nothing but e power x. Now again method says that replace d with a. Here x 1 by f dash of a into e power ax. Now this is the required pi provided that f dash of a not equal 0. If this f dash of a equals 0, the method says that put one more x in the numerator, differentiate the denominator one more time with respect to d, then we get here x square by 1 by f double dash of d into e power ax. Again replace d with a, then we get x square by 1 by f double dash of a into e power ax, provided that denominator not equal 0. Now this is the procedure. Now method 2 or rule 2, when q is either sin ax or cos ax. Method 2 is when q is either sin ax or cos x. Even we can write sin bx plus c or cos bx plus c. In this case method says that pi equals to 1 by f of d into q of x. Here replace d square with minus of a square. Wherever d square is there, write down minus of. In this case replace d square with minus of a square. Wherever d square is there, write down minus of a square. In place of d, don't write anything. In place of d square only we should write minus of a square. Then we get replace d square with minus of a square. In this case we get 1 by f of minus a square into q. q is either sin ax or cos ax. Here in place of d square only we write minus of a square. Now if this denominator is not equal to 0, this gives the required particular integral of the problem. If this denominator is 0, method says that put x in the numerator, differentiate the denominator with respect to d. Here q is there, that is either sin ax or cos ax. Again replace d square with minus of a square. In place of d square we write minus of a square into q. If this denominator not equal to 0, this gives the required pi. If it is 0, put one more x in the numerator, differentiate the denominator one more time with respect to d, again replace d square with minus of a square, and so on. Now this is the procedure to find a particular integral when q is either sin ax or cos ax. Now let us discuss some examples. Let us solve this problem. Solve Let us solve this differential equation. Clearly it is a linear DE with constant coefficients, and here right hand side we have e power 3x, q is nothing but e power 3x. Now in this case we use method 1 to find particular integral. Now first let us discuss how to find complementary function of this problem. To find complementary function, let us take right hand side as 0. This is the given problem. This is the given differential equation. To find complementary function of 1, let us consider to find complementary function, or you can say yc of 1, consider right hand part as 0, that is d square y by dx square let us write like this. Now write down this differential equation in operator form. This can be written as this can be written as like this. The given differential equation can be written in operator form as like this. Now let us write the auxiliary equation. Auxiliary equation is given by f of m equals 0, that is nothing but m square plus 2m plus 1 equals 0. Let us solve this quadratic equation. You will get m equals to minus 1 minus 1. Now these are the roots of this auxiliary equation. Now clear their roots are real and repeated. In this case complementary function is given by complementary function, we write it like this: c1 plus c2x e power minus x. Now this gives the complementary function where c1 and c2 are arbitrary constants. Now let us find a particular integral when q equals to, in this case q is e power 3x. So let us write here q is e power 3x. So let us find a particular integral pi equals to or we can say yp 1 by f of d into q. Here in this case q is e power 3x, f of d is d square plus 2d plus 1. Now the method says that replace d with a. Here a is nothing but 3. Here a is nothing but 3. Now it is of the form e power ax, so a is 3. So simply replace here d with 3. Now we get here 1 by 3 square plus 2 times 3 plus 1 into e power 3x. So we get 1 by 9 plus 6 plus 1 into e power 3x. This is nothing but 1 by 16 into e power 3x. Now this is the particular integral of the given problem. Now required general solution is given by, now required solution of 1 is y equals to complementary function plus particular integral. In this case complementary function is c1 plus c2x into e power minus x plus particular integral is 1 by 16 times e power 3x. This we are writing by star and double star. Now this is the required solution of the problem, where c1 and c2 are arbitrary constants. Okay, let us discuss next problem. Let us discuss another one. Solve let us try this one. Now clearly it is a linear DE with constant coefficients, and clearly it is a non-homogeneous linear differential equation because we have right hand part as a function of x, it is not equal to 0. So in this case first we will find a complementary function by taking right hand part as 0, then we find particular integral using the method 2. Now let us discuss how to find solution of this problem. Now first write down what is given. Given differential equation is, straight away I am writing in operator form. This is the given differential equation. Now here it is of the form f of d into y equals to q of x, where f of d is nothing but d square plus 5d plus 6 and q is nothing but e power 2x. Let us write a complementary function of this problem. Complementary function, first let us find roots of this auxiliary equation, then we will write complementary function. Let us find the roots of auxiliary equation. In this case auxiliary equation is given by f of m equals to 0, that is m square plus 5m plus 6 equals 0. By solving this quadratic equation we get m plus 2 into m plus 3 equals 0. So we get m equals to minus 2 and minus 3. Now these two are the roots of this auxiliary equation. Clearly these two are real and distinct. So let us write first a complementary function. In this case, complementary function is given by, your roots are real and distinct. So we write like this. This is a solution corresponding to first root. Now this is a solution corresponding to second root, where C1 and C2 are arbitrary constants. Now this is the complementary function of this given problem. Now let us find a particular integral. Now Pi equals to 1 by f of d into q. Here q is nothing but e power 2x, and f of d is nothing but d square plus 5d plus 6. Okay. Now here put d equals to 2. Replace wherever d is there with 2. 1 by 2 square 2 into 5 plus 6. This is nothing but 1 by, we get 20 e power 2x. Now this is the particular integral of this problem. Now finally general solution is given by, required solution is given by required solution of 1 is complementary function plus particular integral. So in this case complementary function is, this is the complementary function, and this gives the particular integral, where C1 and C2 are arbitrary constants. Now this is a solution of the given problem. Let us discuss another. Okay, let us take the next problem. Solve let us take this problem. Clearly it is a linear DE with constant coefficients, and here q equals to sine x. Let us find solution of this problem. This is the given problem. Directly this is given in operator form. This is given in operator form as like this. Now this can be written as f of d into y equals to q, here where f of d is given by d square plus d and q is given by like this. Now let us write a auxiliary equation here. Auxiliary equation is f of m equals to 0, that is nothing but m square plus m equals 0. If we simplify this one, we get roots of this auxiliary equation as 0 minus 1. Clearly these two roots are real and distinct. So write down complementary function of this d as like this: c1 e power 0 into x plus c2 e power minus 1 into x. This is nothing but yc equals to c1 plus c2 e power minus x. Now this is the complementary function of this problem, where c1 and c2 are arbitrary constants. Now let us find a particular integral. A particular integral is given by pi equals to 1 by f of d into q. In this case f of d is 1 by, here f of d is d square plus d and q is sin x. Now it is of the form q equals to sin ax or cos ax form. So here method says that replace d square with minus a square. Here sin ax, so it is sin x, so simply a equals to 1 here. So put like this. In place of d square we write minus 1, wherever d square is there write down minus 1 sin x. Now in place of d we will not write square root of minus 1 like that, we keep it like that only. Now to find a particular integral, you multiply and divide with d plus 1. We multiply and divide with d plus 1. If you multiply and divide with d plus 1, we get like this. We get d plus 1 by d minus 1 into d plus 1 into sin x. Now a plus b into a minus b formula, using that formula we can write d square minus 1 into sin x. Again use method 2, replace d square with minus 1. Now, wherever d square is there write down minus 1. So we get minus 1 into sin x. This is minus 1 by 2 times d plus 1 of sin x. Now as we discussed, d is nothing but differential operator. D is differential operator. So d of sin x is simply cos x, and d of sin x is simply cos x. So you write down minus 1 by 2 times cos x plus sin x. Now this is the particular integral of this problem. So finally we write a general solution as, we write required solution of the problem as like this. Required solution of 1 is complementary function plus particular integral. The complementary function in this case is, we will see what is the complementary function in this case. Now this is the complementary function, c1 plus c2 e power minus x. c1 plus c2 into e power minus x. Particular integral is minus 1 by 2 times cos x plus sin x. Now this gives the required solution of the problem. Solve. D square y by dx square plus y equals to cos x. Now clearly it is a linear DE with constant coefficients, and it is a non-homogeneous one because right hand side is function of x is there. So let us solve this one. To solve this one, first write down what is the given DE. This is given. This is the given DE. This is given DE. Write this in operator form. This can be written in operator form as like this. Where f of d is nothing but d square plus 1 and q is nothing but f of d is nothing but d square plus 1, q is nothing but cos x. Now first find complementary function of this problem. To find complementary function, let us consider auxiliary equation. Auxiliary equation is given by, that is m square plus 1 equals 0. Solve this quadratic equation, you will get m equals to plus or minus I. Now clearly the roots are complex and distinct. It is of the form alpha plus or minus I beta. In this case alpha is 0, beta is 1. Now we will write a complementary function of this problem as like this. Complementary function is given by yc equals to, or cf equals to, e power alpha into x into c1 cos beta x plus c2 sin beta x. Now this is nothing but c1 cos x plus c2 sin x, where c1 and c2 are arbitrary constants. Now let us find a particular integral. A particular integral is given by, now pi is given by, we can say pi or yp 1 by f of d into q. In this problem, f of d is nothing but d square plus 1, q is nothing but cos x. Now this pi can be found by method 2 because q is nothing but cos ax. Here q is of the form cos ax. Here a equals to 1. The method says that put d square equals to minus of a square, that is minus 1 square, that is minus 1. By writing d square equals to minus 1 in the denominator, this denominator becomes 0. So this is not the particular integral of this problem. To find particular integral, we place x in the numerator, put x in the numerator, differentiate the denominator with respect to d. So d square derivative is 2d, 1 derivative is 0. Write down cos x as it is. Now again using method 2, replace d square equals to minus a square, but here there is no d square. So to find pi of this, divide with d, or we can use this operator. This is called the integral operator or inverse operator. We can say this is integral operator or inverse operator. Using that one, 1 by d of cos x means simply integration of cos x is sin x. So this is the particular integral of this problem. So finally we write general solution as required solution of the problem is 1 is complementary function plus particular integral. In this case complementary function is c1 cos x plus c2 sin x, and particular integral is this one. Now this is the required solution of the given problem. Thank you.